Okay, in today's section, we will study how to compute a volume bounded by some function on some specific domain, right? So take a look at at the rectangular box here, V. We see that the base, what is the area of the base here? Louder, please. Perfect. The area is the length times the width. We're not talking about the volume yet. But now, in order to compute the volume, we need to multiply with the height of that, right? That gives us the volume of this one. The same ideas, if we are given a circular cylinder with the base is a circle. So what is the area of a circle? Pi times square root of pi times r squared, right? Where r is a radius. And similar story. The volume of that would be the pi, the area multiplied with the height. Okay? Or sometimes we're given the cylinder with the base B1 and B2. They are the same, but in different plane. Okay? And the height of this cylinder is h. So in general, this volume will be the area, the base area multiplied with the height. So the same idea, if we're given an object, as in the figure here, and the volume of this will be the delta x, for example. We use Riemann approximation, the same idea here. Will be the area here, right, multiply with the width in the x direction if we take the delta x is very small. And the same idea is a Riemann sum of n terms, right? If we discretize the interval from a to b to be very small, and we take integral from a to b of the area s here multiply with delta x. This will give us the volume of this from, so is the idea clear? Similar to area of an integral. Okay? And remember, the area of moving cross section is perpendicular to the x-axis here, which is the red area, as you can see here. And in some specific case, the cylinders you can see, right? Then it gives us the same result as A times B minus A. B minus A is the height of this cylinder. So that is the idea. And we will focus on that in the whole section here. Now, let us consider this example. We need to prove that the volume of this sphere with the radius r is given by this formula. Okay? This is what we need to prove. And now with this section, we need to imagine more than usual, right? If a sphere is this, then in the OXY plane, if we are given the radius r here, right? And the position in the x direction is, suppose it is fixed right here. then can we compute the y coordinate of this point? Right, in the plane OX, Y. In the plane OXY is simply a circle, right? And this is the equation of the circle. So suppose we are given R and we are given X. Can we compute Y? So how can we do that? Okay, very good. Now if we subtract both sides by X squared, we'll have Y squared here, right? Very good. And then Y will be, after that we can take square root both sides, right? Okay. And Y will be square root of this, or more precisely, absolute value of Y will be square root of R squared minus X squared. Okay. So if Y is positive, then Y will be R squared minus X squared here, right? If Y positive. If Y is negative, then Y will be negative of R squared minus X squared. Okay, these are some relation. So now the same ideas. So at each given position X here and R, we can compute Y, and therefore we know the circle, the red circle here, right? You all see it? If we're given the position X here, R is given and it is a fixed number, so we can compute this circle, the red area. So, and what is it? Suppose we call it S. This part. So what is the area of this?
Y squared.
Perfect. Is it Daniel?
Yeah.
Perfect, very good. So Y squared, we can write it in terms of X and R, right? So what is it now? If we replace Y by X and R? Very good. R squared minus X squared, right? So this is the area here. In order to compute the volume of this, let us take the integral from negative R to R here of S delta dx, right? From negative R to R, which will give us the volume of this guy, right? So the difficulty of these types of problem is how to determine the area of what we are computing, and then let the yeah, that's it. Just okay. So because delta x is replaced by dx here, right? So integral. So we have that this is AX. Yeah, let us use that AX here to have the same notation with this. Okay, the volume will be integral from negative R to R of AX dx. And as we compute it here, AX is pi R squared minus X squared dx, right? Very good. So pi, is it a constant or is it a variable? Constant, right? And R, is it a constant or a variable? I'm sorry. Yeah, in general, it is a variable, but this is a fixed sphere with a fixed radius. So R is a given number, right? So we can treat it as a constant. So, in other words, we can write this guy as pi, a constant we can take out of the integral, right? Here is R squared minus X squared, okay? Dx, integral from negative R to R here. Again, which properties should we use here to get an easier computation? We don't have to, just do it, okay? Let's try. So what is the antiderivative of R squared? It's simply a constant. R cubed, is it right? It is a constant. R squared and, yeah, X, right? Because we are taking the integral with respect to X, right? R does not depend on X. It is simply a constant. So, very good. And how about X squared here? Very good. From good job. So is it clear? So now we replace the value here, right? With the upper limit, we have pi is here. It will be R squared times R minus here, right? That is the value of the upper limit. The same story, minus pi, the lower limit here is negative R, right? So it will be, okay, minus, very good. Good job. So let us simplify it. This is pi, and here will be R cubed, very good, minus R cubed, right? Over 3. This here will be pi. This is negative R cubed, okay? Good job. And here, very good, R cubed over 3, okay? Now, we simplify it, we can file it here, right? Give us pi. Let us do this guy first, right? Whatever weight, we can distribute it, whatever. R cube minus or I think it's better to factor it, right? We don't want to write so much. If we factor R cube here, what do we have? Very good. If we factor R cube here, what do we have here? Yeah. Then again, R cube and pi R cube, we can factor it out, right? So what do we have inside this? Yeah, 1 minus or 1/3, it will be 2/3. Very good. And here, negative 2/3. Good job. Okay. It will be pi R cube, and this guy will be plus 4/3, right? Okay. Just numbers. So you can do in your ways. It's up to you, but factor it, make it easier. So do you have any question about this? Very good. So it's clear, right? So if it's clear now, then yeah, and here you can see the solution. Double check it. And this is a illustration of our problems. We Riemann approximation of this. If the dx is finer and finer, it will become closer and closer to the real volumes, right? Yeah, the Riemann sums, you can do it this way. I from this, if n becomes very large, then it will be very close to the real volume. So, and the similar story, sometimes we can compute the area with respect to dy if the equation is easier in this way, right? The same idea, but switch the role of x and y. So if we are given a cross section, okay? If we are given two functions, f here and g is below, for example, or look at this domain. The radius, the inner radius here is given by this line. And the outer radius is given by this line, okay? Then at each intersection, the area will be this guy, right? From here to here. And then if you rotate this with about the x-axis, it will give us the volume of this guy, right? In a finite change of dx, very small dx, it gives us the red area here, right? So the same idea, if we need to find the volume of the whole object here, we'll have to take the integral from the left position here to the right position of the difference of the outer radius and the inner radius. Okay? But the idea is the same. Now let us play with some more example. So find the volume of the solid. Obtained by rotating about the x-axis. The region under the curve y is equal to square root of x from 0 to 1. Illustrate the definition of the volume by sketching a typical approximating. Okay. Before solving this, let us try to illustrate this function, right? Okay. So you can sketch the function following the steps in the chapter 5, right? The domain and everything. For the easiest way, here we know that y is equal to x, square root of x here. At x is 1, from 0 to 1, right? So at x is 1 here. What is the value of y? Very good. At 1, y will be 1. Therefore, this is a point of the graph. At x is equal to 0, y will be 0. Right? This is y equal to square root of x. When x is negative, yeah, y is negative, then it should be like this. It's symmetry with respect to y. Okay, just okay. From 0 to 1 here. So at the position x, suppose it is right here in the middle. What is the value of y? If at the point x0 here, what is the value of y? square root of x 0, right? Because it should follow this line, right? This formula. So this guy, if x0 plus h is this one, then if this red area here rotate about the x-axis, what do we have? So we will have this area, right? If it rotate about x-axis. Then according to the application of integral, if we take the integral of this area here, this line, the area here from, if we rotate it about the x-axis, it will give us the area of this red area, right? Do you see it? Just imagine the line here from x0 to square root of x0, and we rotate it, give us a circle, right? And what is the area of that circle? You can imagine this way, okay? In 3D, do you all see it? This guy. I draw it here so that I hope that it will help you seeing it better. You see it? The line here, then you rotate it about the x-axis, right? See it? This line. So it will becomes a circle, right? And what is the area of that circle?
Pi x.
Pi multiplied with r squared, right? And what is the radius in this case at x0? Perfect. Square root of x0 is the radius, the distance here, right? Or it will be pi of square root of x0 squared. Do you all see it? And we know that x0 is between 0 and 1, right? And in general, x0 will move from 0 to 1. Or we can write it in for as a function of x, then the area of this guy will be pi x square root of x squared, right? Or it will be pi x, does it? Okay. So the volume of this guy, of the whole area, it will become this area. It will cover all these. So the volume will be integral from 0 to 1 of Sx dx. Okay. So do you agree with that? And Daniel, do you agree with that?
Yes.
Perfect. Vikram and Gary and everyone from the back, do you all see it? Is it clear? So now it becomes easy. The difficult part is how to imagine what we're doing. Now we've got everything clear. it becomes a very easy integral, right? So integral from 0 to 1 here s of x is pi x dx, okay? Pi is a constant, so we can take it out, right? Integral from 0 to 1 of x dx. So what is the antiderivative of x here? Perfect, x squared divided by 2. And running from x is equal to 0 to 1, right? So it would be pi n. Very good. Okay, that's it. So our job is to determine, okay? So let us move on to another example. Find the volume of the solid obtained by rotating the region bounded by y is equal to x cubed, y is equal to 8, and x is equal to 0 about the y-axis. Okay, it looks complicated. But let us try to illustrate the graph and see, right? Y is equal to x squared. We can sketch the graph here by taking the derivative by the x-intercept, y-intercept, the increasing, decreasing area, whatever. And you see that it will be like this. At 1, it will be 1. At 2, it would be 8, right? Right. Yeah, it's not very good, but yeah, you can do it better. So rotate, obtained by rotating the region bounded by y is equal to x cubed, and the line y is equal to 8. Huh, interesting. So I think I need to draw a better one. Let me draw it again. If we continue drawing this guy, at 2, it will be let us say it is 2. At 2, it will be 8. Yeah, this is y is equal to x cubed y, right? This is 8. Okay. And the line y is equal to 8. This line, right? So and the x is equal to 0 axis. X is equal to 0. It will be the y axis, right? Okay. This is 0. So it means the green area here, and then it rotates about the y-axis. Okay. Do you all see it? Very good. So it means that at each position here, we need to determine see. Yeah, let me try it here this way. Yeah, see it, right? When you rotate it about the x-axis, you see that this will create a circle, right? And what is the area of this circle? Suppose this is the point x, y0. The center is y0. So what is
it X?
this is y0 in the y-axis here. It rotates about the y-axis. So at the position y0 between 0 and 8, right?
Is the radius of the circle X?
Oh, you mean, okay, let us see. So this point will be a solution of this guy, right?
Yes.
So if this is y0, what is the position of the corresponding value x?
X0?
X0 cubed. Very good, Carson. Yeah. Here, then this position will be y0, right? It's satisfying this equation, the relation of x and y. You see it? You don't have to be rushed. Just think about it and make sure that you see it. Then we'll continue. If not, we'll keep talking about it. this is a line, right? Then we rotate this red line about the y-axis. It will draw a circle here, right? But remember, the radius of this circle is the distance from y0 to this point. And this point is the point belong to this axis, graph yx cubed. Therefore, if we're given the y coordinate, then the x coordinate will be this guy, right? Okay. So what is the area of this circle? It will be this distance, right? And this is x0. Okay. From this relation, we see that x is square cube root of y. Okay. And here it will be pi x0 square, right? The distance here. And x0 is cube root of y0 then square. Is it clear? Let me write it down here. S of x. So in general, x0 here and y0 here will run from 0 to 8. It will be pi, and it will be y cube root and then square, which is pi y to the
2/3.
Very good. So, and the integral from 0 to 8 with respect to the y coordinate will give us the volume of this guy, right? So, let us write it in y, sorry. Okay. Sorry, it depends on y, okay? So the volume will be integral from 0 to 8 of sy dy. Are we good? Do you have any question up to here? It's good, right? Then we substitute the value of sy. It will be integral from 0 to 8 of pi y to the 2/3 dy. Okay? Antiderivative of this guy, it will be y to the 2/3. Remember, antiderivative is the reverse of derivative. Therefore, this will be 2/3 plus 1. And then, what should we do? Very good. divided by the same power here, so that when we take the derivative, they will cancel each other, okay? So if we do this guy, pi, it would be pi 1 divided by 5/3. And this is y of 5/3. Oh, remember, from 0 to 8, right? And it would be pi multiplied with the reciprocal of 5/3, which is 3/5. Y to the 3. And y is equal to 0. Y is equal to 8. So from this, we can easily compute that becomes 96 pi/5. Go home and double check it. So I'll see you tomorrow. Remember, we have a quiz. Bye, everyone.